Hi everyone. Today we're going to go through molecular mass and the mole. This will be lesson 2.6. Okay. Now, there is a relationship that exists between the mole and the atomic mass of an element. So remember, the atomic mass comes from the periodic table, okay? So the atomic mass, you look at your periodic table in order to find that. Now, elements, let's just go through a couple examples here. So we've got carbon and we've got nitrogen here. So carbon, if you look it up on the periodic table, has an atomic mass of 12 atomic mass units. Now, I'm going to tell you the mass of 1 mole. So 1 mole would be how many, first of all? How many atoms would that be? Yeah, 6.02 times 10 to the 23. That is going to be 12 grams. So this is actually where we get the number for mole from. So we know that 12 grams, if you measured out 12 grams of carbon, you would have 6.02 times 10 to the 23rd moles. And so that's where that number for the mole is all based off of. And because of that, it allows us to have this relationship between atomic mass and the mass of 1 mole. Nitrogen, the atomic mass from the periodic table, 14 atomic mass units. And so if you look here, the mass then of 1 mole of nitrogen is going to be 14 grams. If we look at magnesium, for example, magnesium is 24.3 on the periodic table, and that's atomic mass units. If you measured out 6.02 times 10 to the 23 atoms of magnesium, it would weigh, or it would mass, to 24.3 grams. So this is the relationship here between them. Now, this also applies to molecules. So for example, water, which is our H2O, it's going to contain 2 hydrogens and 1 oxygen. So the molecular mass would be, you're going to have 2 hydrogens plus 1 oxygen. And so that's going to be 2 times 1.01 plus 1 times 16. So you're going to get 18.02 atomic mass units. So if you had 1 mole of it, it would weigh 18.02 grams. Okay, so that, oh, I forgot I had that on there. So the mass in grams of 1 mole of a substance is called its molar mass. So we're going to use this term here. The unit for this is going to be grams per mole. So if I ask you to find the molar mass of something, the unit is grams per mole. And we're going to use this concept to convert between moles and grams of a substance. All right, so an example here, what is the mass of 0.25 moles of sodium hydroxide? So we're going to use our dimensional analysis to solve these. So what are you looking for? You're looking for mass. I never write the word mass, I just write grams there because that's the unit that I'm going to say my mass is. So grams equals, now what do I know? I know I've got 0.25 moles of NaOH. So now I draw my bracket. The unit that goes to the bottom, diagonal units here, is going to be our moles of NaOH. On top is grams of NaOH. And I know, because I know from this relationship here, I know that this applies to molecules. So the atomic mass units, if I have a mole of them, will be equal to that value in grams. So I'm going to find the formula mass for NaOH, so sodium hydroxide. So I'm going to end up with 40.01 when I do that. And this came from the periodic table, okay? So I add up 23 for the sodium, 16 for the oxygen, and 1.01 for the hydrogen, and I get 40.01. Now, that I know this is my conversion factor because I know that 1 mole of sodium hydroxide is equal to 40.01 grams of sodium hydroxide. So this is a conversion factor here, okay? And now you would just do the math on this, and of course you end up with 10 grams of NaOH, and your moles are going to cancel and you end up in grams, which is good. Now remember, you need either a decimal there or you need the bar on top to indicate that there are 2 sig figs for that one. Okay, the next one. Convert 2.3 grams of sodium atoms into moles. So if you had 2.3 grams, how many moles would you end up having? So what are you looking for? You're looking for moles. Moles equals 2.3 grams of sodium, okay, atoms. And then we're going to have our conversion factor here. Now you've got grams of sodium on the bottom and moles on top. In 1 mole, how many grams of sodium are they? And this comes from the periodic table. That's 23. So I know that the molar mass is 23 grams for every 1 mole here. So 2.3 divided by 23, we're going to get 0.10 moles. And again, our grams are going to cancel and we're ending up in moles. So that's good there. And pay attention to your sig figs. Okay, so I needed 2 sig figs in that answer. Okay, I think this is our last, no, a couple more actually. So, and again, you should be trying these on your own, right? So pause the video and give this a try before you watch the answer here. So how many moles in 2.41 times 10 to the 23rd atoms of copper? So for this one, you're looking for moles. Again, what are you looking for? Equals what do you know? You've got 2.41 times 10 to the 23rd atoms. Now we're going to draw our brackets for our conversion factor. Atoms goes on the bottom, moles goes on the top, and I know that in 1 mole, how many atoms do we have? Right, 6.02 times 10 to the 23rd. So now for that one, if we do the math on that, so this was actually from what we did yesterday, right? And so now we've got 0.400 moles of the atom, of copper, sorry, that's copper. Just making sure I did the math on that right. Yeah, good. 3 sig figs for your answer on that one. Okay, and this one, convert 0.354 moles of lithium chloride to grams. So what are you looking for? You're looking for grams, and you know that you've got 0.354 moles. Now here's, if you don't know how to write this formula correctly, you won't get the right answer, right? So lithium chloride, you need to know that lithium has a charge of 1 positive, chlorine is 1 minus, so they bond in a 1-to-1 ratio here. So lithium chloride here. So now we're going to draw our brackets. Moles of lithium chloride goes on the bottom. Grams of lithium chloride goes on the top. And now we have to add those together. So it's going to be 35.5 plus 6.94. And so I know that I've got 42.44 grams for every 1 mole. Moles are going to cancel. I end up in grams, so I multiply that number by 0.354, and I get 15.0. So 3 sig figs here in my answer. Grams of lithium chloride. Okay, you can try now exercises 7 and 9, and again, you have the answer key, so make sure you're doing those and are asking questions if you're not getting the right answers. Okay, thanks everyone.